The melody you have just heard is completely computer generated. I have implemented a melody generation algorithm into Max that triggers when I'm playing specific chords. The type of the chords, the root notes determine which scale gets used real time in the generation of the melody. This makes it possible to have interesting computer generated modal solos. You can use this to create many interesting musical constructions. Let's see how this is possible. The algorithm I want to implement comes in a few parts. First of all, I want to determine the type of chord that is played. And then I want to use this information to set the scale and parameters of the melody generation. And then of course I have the melody generation, which I will define as play X amount of scale notes. We can later add in more rules, more ideas to make this a bit more intricate, but I want to start by just playing scale notes going up and down certain amounts of intervals, maybe some gaps in between to create the perception of rhythm. And I want to start with this part. I want to start with the last part because melody generation is maybe the most interesting part of this all. And here's how I'm going to do it. First, I want an integer number box that I'm going to treat as my scale steps or my scale degrees. 0 would be the first one, 1, 2, 3, 4, 5, 6. Let's say I have a 7-note scale, so when I arrive at 7, I'm back at the first degree but an octave higher. And I can keep going like this. 13, 14 would be again the first degree but 2 octaves higher. Then I go through the whole scale 2 octaves higher, and so on and so on. If I implement a system like this, then I can just continuously go through all possible scale notes, let's say, on the keyboard. And for this, I'm going to use ZL lookup. The ZL family of objects is, of course, for processing lists, and ZL lookup is going to receive a list in its second inlet, and it's going to use the integer values coming into the first inlet as an index number to read from this list that is going into the second inlet. So 0 would be the first element of this list, 1 would be the second would be the third, or 2 would be the third, and 3 would be 4. It's always a bit confusing when we start thinking of 0 as the first index number. But doesn't matter. So let's define a scale as a series of intervals, right? The question I'm asking is, what do I need to add to my current note in order to get the right amount of intervals for, let's say, a major scale? So I start with the same note, I add 0 semitones, then I have the major second, the major third, the perfect fourth, 0, 2, 4 would be a major third, and 5 would be a perfect fourth, a perfect fifth, a major sixth, and a major seventh. So these intervals would constitute a major scale, right? So I can connect this here, I can send it by clicking this message box. So now ZL lookup has this list loaded, and then I can browse through this list. I can use this as a list of intervals to be added to some kind of base note. As you can see, 0 is 0, 1 is 2, 4, 5, 7, 9, 11, and then it does not go up. And this is exactly what I need to figure out, right? So on the one hand, I need the scale note index, let's call it that. And on the other hand, I need my octave. So which octave am I at? And to have consistent scale note indices, so let's say I go from 0 to 6, then instead of 7, I loop back to 0, I simply need to use the modulo operators, modulo 7. If I do this, and I can also visualize the result like this, I can start by 0, 1, 2, 3, 4, 5, 6, and then 7 would become once again 0. I will loop through this again, and each time I arrive at a multiplication of 7, I just loop back to 0 instead. So I'm just constantly cycling through my scale, the intervals of my scale. And this can go as high as you want. The result is always going to be something between 0 and 6. Which is of course really nice, but we also need to figure out the octave. And I'm going to do this by doing a little bit of a mathematical trick. By this I mean using the division operator with an integer number. So divide by 7. Notice that I don't have the decimal dot here, so I'm not going to get a floating point number. I'm going to receive an integer number, which creates an interesting effect. So let's say I have 1 divided by 0, which is 0.1 something something something. I don't know that off the top of my head, but since there is no decimal dot here, since this information is being sent to an integer number box, it's just 0. And I can keep going like this, 5, 6, 7, and then it's going to be 1. It's going to stay like that until I arrive at 14, and so on and so on. And this is a perfect indication of which octave I am at, or how many octaves do I need to add to my resulting notes. Right, so if this is at 0, this 0 here, as a result of the division, would mean add 0 octaves. If I'm at 7, this means add 1 octave to the result. If I'm at 14, add 2 octaves to the result. So let's think about how we can implement this. So here I have the interval I want to add, and if I have an octave here, I want to add 12 semitones. I want to add a whole octave to the result of ZL lookup, meaning that add an octave and then this interval to get the right scale note. So I can simply use the plus operator. On the left-hand side, I have the results of my ZL lookup, and on the right-hand side, I'm just going to have the octave number multiplied by 12. So 0 octaves is 0, 1 octave is 12, meaning 12 semitones, 2 octaves is 24 seminotes, and so on and so on. And this should, in principle, give me what I require. So 1, 2, 3, 4, 5, 6. And now we keep going. So as a result, at the end of this chain of operations, this algorithm, we have the right intervals that we need for our scale notes. Now, let's try to play this. Let's try to have some kind of output, right? And I can visualize this on a key slider, for instance, because we can treat these as MIDI notes. Right? Because these are intervals to be added, but we can think of these intervals as they're added to the note 0. And the result, I can, let's say, create a make note, the velocity 110, duration, let's say 500. And I'm also going to use the attribute of repeat mode 2. This is going to help me later if there's a note repeating with make note. It is going to stop the currently playing note and then repeat it. This will be useful later if we want to have repeating notes as part of our melody generation. And the results I want to, let's say for now, let's just use note out. Maybe later we can involve VST instruments, but I can do it like this. Or actually, no, I want to use VST instruments. So I'm going to take the result of make note. I'm going to join this result in. I'm going to put this through MIDI format. And I'm going to send the second outlet of MIDI format into a VST instrument. To do this, I can go left, the plugins. I can, let's say, VST plugin and Spitfire Labs. So the second outlet of MIDI format goes into here, then Labs is going to send out an audio signal which I can play by using Easy DAC. And let's say we use a piano sound. Sounds really nice. So I can now play my instrument like this by using this VST instrument, but I can also cycle through the scale notes of the default C major. If I keep going up. Great, and if I want to modulate this, if I want to have, let's say, F major instead, I just have to add an offset after I calculate my intervals. So let's say we are at C, right? So I want to go to F, so that's 1, 2, 3, 4, 5 semitones higher. So if I say plus 5, if I add 5 to every note, I'm going to get the F major scale. Awesome. Now let's continue by having the play X amount of scale notes part of our melody generation. And here is what I want to do. So I want to have a button, and I want to have it so when I press it, it plays 15 notes at a certain tempo, at a certain BPM. And when it's done playing this, the whole system stops. And while it's playing, I want to take a starting note. Let's also write this down, actually. It's always useful to write these steps down so I do not forget them. I want to have a starting note. And on each step, and this is the important part, right? I want to have this, this random chance process. So on either step, the options are to go 2 semitones higher, or I want to go 1 semitone higher. Or wait, I don't want to go a semitone higher, do I? I want to go a scale note higher. So go 2 scale notes higher. Or I can go 1 scale note higher, which is, a smaller interval, so we have some variation. I can also have this in the other direction, so go 2 scale notes lower, or go 1 scale note lower. Or I can, let's say, repeat the current note, or I can just not play anything. And after I do this, after I send this information and I, play the resulting sound, if there's a resulting sound throughout the system, I want to save the resulting note as the starting note. So when I trigger this process again, I continue from where I have left off. This will create a melody, some kind of basic melodic gesture. And let's not think about the X amount of scale notes thing for now, and let's just make this happen each time I press this button, each time I send out a bang. There is this process that does all this. And for this, I'm going to use the integer value object. Int, short for integer, will store an integer value. By default, this will be 0. I can give it an argument for a starting value. And this is a very useful object for such circular feedback algorithms that deal with integer numbers. And here's how this works. If I send this int 30 a bang, it is just going to send out whatever value is saved here. But if I send another integer value to its second inlet, it is going to overwrite 30 with that value. So because I have sent 20 to the second inlet here, now this object does not have 30 inside, but it has 20 instead. If I send out a bang, I get 20. So I can start with 30, and once I'm done with my whole process, the result, I can plug it into the second inlet. So when I start this process again by clicking this button, I'm going to start with the results of the previous step. Hopefully that makes a little bit of sense to you. So let's try to implement this. Let's start with 30. And let's say I press this button, this 30 value is sent. And before I process this information, I want to figure out which one of these steps, which one of these possibilities are going to happen. And to make this video not 2 hours or 3 hours long, I already have no idea how long this video is going to be, I want to use just plain old random chance. If you're familiar with the drunk object, for example, you can use that, but I want to go a bit lower level and I want to just use random. So let's see, I have 1, 2, 3, 4, 5, 6 possibilities if I'm counting this right. So I'm going to say random 6, which is going to give me values between 0 and 5. Right, so each time I send a bang to random, it's going to give me a random value between 0 and 5, integer numbers. And I want to select these values, right? So I'm going to use cell, and the arguments are the possibilities, which is 0, 1, 2, 3, 4, 5, and not 6. 6 is not inclusive because this is random 6. And if I do it like this, then I'm going to receive bangs from these outlets depending on which value it receives. If it's 0, it's the first one. If it's 1, it's the second one, and so on and so on. See, if each time I'm clicking it, a different button or the same button lights up depending on the results of this random chance. And I can use this, I can use these bangs that are being sent out of cell to trigger different procedures. So I send my bang here, the integer number is being sent, but before that I already want to determine what happens, right? So I am going to use the trigger object, or T for short, to have a very specific flow of operations. So TIB. Right, what does this mean? Trigger is from right to left. So first I'm going to send out a bang, and then when that bang triggers all these processes and they're all decided, then I'm going to send out I, the integer number that is coming in. Okay, now let's see, what do we need to do? I think the first 4 options are, well, the first 5 options are the easiest. So how do I go 2 scale notes higher? I just add 2 to my current integer number, which is representative of the scale note index. To go 1 scale note higher, I add 1. To go 2 scale notes lower, I subtract 2. To go 1 scale note lower, I subtract 1. And to repeat the current note, I don't do anything. So these are all mathematical operations, right? So I can receive this integer number. And before I send this integer number through this plus operator, I can just set the right operand. I can set if I add something or subtract something, or I just keep it 0, meaning just this value just passes through. So let's just create a bunch of message boxes. So 2, for example, for adding 2 seminotes, 1 for adding, again, I'm saying it wrong, not seminotes, scale notes, 2 scale notes, 1 scale note. Let's say 0 would be, don't add anything, just let that scale note pass. -1, I would add -1, meaning I subtract 1 scale note from the current scale note, or -2. Right, so if I have it like this right now, since I'm not updating my integer, my int object, each time I do this, I'm going to get variations on 20 because I forgot to reset my int object. Now each time I'm going to get variations on 30, 30, 28, 32, 30, 28, 31, 32, 29, or 30. So something between 28 and 28 and 32, I believe. The tricky part is the last ones. How do I don't play anything? And to do this, I can simply use the gate object, which is going to pass input to an outlet, right? So I'm going to have this gate that will be closed if I don't play anything, and if I'm going to play something, the gate will be open, so the scale note will pass through. So my gate will have only one outlet, either I pass something or I don't, and the second argument is the initial state. By default, I want this to pass things through. Right, so to the right inlet, I put in the value that is going to be passed out of the outlet. And to the left inlet, I need to send if this gate is open or not. So let's say the random gave us 5, which means nothing is going to be played. So I just send 0 to the first inlet of gate. So whatever comes in here doesn't matter. Gate will not send out anything. But the problem is, then in this case, I also want to send the message 1 to the gate each time I trigger this operation, because if this gate is closed, I don't want it to stay closed. I want to have it so at the beginning of this whole process, the gate is open, and then either we decide that the gate is closed or the gate stays open and we add or subtract scale notes. So I can add another step. I can just simply write 1. I can type 1 as an argument to trigger. So now first, this is going to send the message 1. Let's send it to gate. Then it's going to trigger all of this. Either it's going to load something here or it's going to just simply close this gate. And then when all of that is set, I'm going to receive my integer number and it's going to get processed. Either it's going to be sent out of the gate or it's just not going to happen. Nothing is going to come out of here in the case of not playing anything. And after I do all this, then I can add the final result to the second inlet of int. So whatever comes out of gate, that is now my starting notes. And this should have give us some kind of motion through these values, right? So 32, 33, 35, and see as I'm clicking, I am going above 30 to 40. With depending on random chance, I might also start going down or up. That's, again, all completely random. So maybe we can also add a reset button. If I go too high, maybe, the piano notes are too high or too low, so much so that they're unplayable. I'm just going to have a message box that says 30. And if I send this to my second inlet, now I'm going to start from 30 again. To combine this idea with our previous idea is actually incredibly easy, and while I'm explaining this, I just noticed that I kind of messed up here. I moved some of the objects down while I did not move some of the other objects, so now it looks a bit goofy, but I can very easily fix this by shuffling some things around. There we go. A clean patch is a happy patch. Okay, so actually, I don't need to do much, do I? I just need to send the resulting scale note information here, and then it should work. And let's reset everything. Okay, we have an improvising computer. It's not a very great improviser, but we can work with this. We can later try to change some of the random chances. Doesn't matter. But before I try to go into the chord detection part, I also want to have the play X amount of scale notes part added into this whole algorithm, right? Because right now I have to press this button to get something or get nothing, depending on what happens with this random object. But I want this to be timed. I want to have some kind of tempo operation. So I'm going to bring this all down, have some more space here, and let's see. So to count, I'm going to use the tempo objects. As an argument, I give the BPM. I see if I divide this beat. I don't, but I want the 16 notes. So 120, 116. And if I toggle this tempo on, this should send me the beat count or the subdivision counts from 0 to 15. I actually don't care about the count of the subdivisions right now. I'm just going to use these as banks, so I'm going to send this to a button which is going to trigger a bank. And once again, I'm going to use a gate object to decide if this bank gets sent out to our melody generation algorithm or not. So gate 1, 0. By default, I want this to be off. So I'm going to send this bank to the second inlet. Again, gate will send this out if the gate is open. In this case, it's closed. And I can use the toggle to determine if this gate is open or not. And already this trigger can be controlled by some other process, right? Maybe something visual, maybe some other input of a musical instrument, of an audio signal. But for now, I just want to count the elapsed notes. And to count, I can of course use counter. Let's see, I want 60 notes, but I know counter is going to start counting from 0, so I will say counter 15. So it will count from 0 to 15. And counter will count when there is a bank coming into the first inlet, and then it's going to send out the count itself. And it's going to loop according to the argument that I give it. So let's see what I want to do. So I want to detect if this counter has looped or if it has reached the maximum amount. And I believe that the third outlet does exactly that. It's going to send out a certain message, I believe the integer value 1, if I have reached the maximum amount, 15. You see that? If it's at 15, then I am receiving 1 here. So I can select this, so cell 1, right? And if there is 1 coming into here, if this cell 1 sends out a bang, I can send this bang message to, let's see, to my toggle, which will essentially turn it off. Sending a bang message to a toggle will turn it off. And this I can use as a counter. Now it's just a burst of 16 notes or 16 note events because it also might not play something on certain steps. Perfect, this is exactly what I wanted to do. And now let's go into the chords detection part. I actually addressed this in another video, so I'm going to be fairly quick about this. There already exists a video where I talk about how to detect chords based on the notes that are being played. So to begin with, I'm going to have my note input, so notes in, right? Maybe we can also route this to another VST instrument, so also what I'm playing with my chords makes sense. So I'm just going to grab join MIDI format and my VST instrument and also the output. I will copy this, I will bring it here. Seems like we need a bit more space. The more complicated the algorithm becomes, the more space we end up needing. And I find that pretty neat. Okay, so the note comes in, we join this velocity and note values, we send it to MIDI formats, and let's say this time I want an electric piano sound. Let's see what I have in my Spitfire audio. VST, organic electric piano, there we go. Let's see. Change it like this. Okay, so I can actually hear what I'm playing now, which is always preferred. Now, when note in is receiving something, I also want to use strip note to filter out the note off messages. I don't want those. And then I can simply use quick thresh to gather all the incoming notes. If they're being played at about the same time I want to have them as a list, I'm going to use ZL sort to sort these numbers, these MIDI values, so they're always from lowest to highest. And then I am going to get the first element of this list by using ZL slice 1. And I'm going to use vexpr to subtract the list, each element of the list, by this first value. So $I2 minus $I1, and I'm also going to use the attribute scalar mode 1 to enable scalar modes, basically, which is going to make it possible to send a single value to the first inlet and apply that to all of the list elements. And this is going to give me what is essentially a prime form of these chords. 0, 3, 7, 10, a minor chord, 0, 4, 7, 11, a major chord, 0, 4, 7, 10, a dominant 7th chord. Neat. All right, and then I just need to use ZL compare to see if this incoming prime form of a chord matches with something. So let's say a major chord is 0, 4, 7, 11, 0, 4, 7, 11. A minor chord is 0, 3, 7, 10. 0, 3, 7, 10. And let's also have a dominant 7th chords. But ideally you can add as many chords as you want using this system. Again, I have gone into more detail in a previous video. So there we go, and there we go. Now these are going to send the messages 1 if the lists match whatever is given as the argument, and 0 if not, so I just want to select 1. So I receive a bang when I know the incoming list, incoming prime form matches one of these, and then I can trigger something here. So let's see, let's think about the scales that we are going to use, right? So for example, I can go to my original ZL lookup and I can send different lists here. Instead of a major scale, maybe a minor scale, a Dorian scale, a Mixolydian scale, right? So I can receive this, 0, 2, 4, 5, 7, 9, 11. And let's say if this is a major 7th chord, send out the required intervals for major scales. If it's a minor chord, let's have it Dorian, right? Let me quickly think about which intervals are necessary. So that would be 0, 2, 3, 5, 6, 7, and 11. Oh, 5, 6, 7, and 11. I think I got this right. If I don't have this right, there should be some kind of correction popping around somewhere, but doesn't matter. Okay, and if I want a Mixolydian scale, let's say, so based on the detected dominant 7th chord, again, we start by 0, we start with 0, And I believe that's the major scale, but with a flattened 7. So 0, 4, 0, 2, 4, 5, 7, 9, and 10. And to make my patch look nice, so I don't do things like this, I'm going to use send and receive objects. Right, so let's send all of these to the ZL lookup, and let's name this scale. So S scale, send this information to a paired return object, R scale, which goes into ZL lookup. And at any instance, I'm only going to trigger one of these. It's not possible for all of these to be right at the same time. Of course, it's either a major or minor or dominant 7th chord, so this is fine. And then I want to, let's see, I want to change my offset here. Right now we were doing the F scale, right? F major or F Dorian or F Mixolydian scale, and I don't want this, so I will keep this empty, and I will send something to this second inlet. And I already know the root note because I'm already considering all of these chords in the prime form, right? So in root position, of course, it's C or A or B or something like that, the very first note of my chord. And that I have already received by using ZL slice, slicing out the first element of this chord, so I can basically use modulo 12 to get the pitch class starting from 0. So 0, 9 for A, and 11 for B, and it will pretty much work. 8 for G sharp, it will pretty much work for anything at any octave. And I can also send this, let's say key tonality, and I'm going to send this information to this plus operator right here. So IR key tonality. Okay, and after I have sent all this, I want to trigger the process, right? And I don't need to do anything else. Oh wait, I do have to do something else. I have to reset this counter. So I want it so each time I press something, we start counting from 0. So if I keep playing notes, the counter doesn't reset, but it just keeps on playing. So each time I press a valid chord, I am going to reset the counter to 0. And for this, I can use the third inlet. If I send a value here, it will reset the counter to the number on the next clock. Meaning if I send the message 0, right, so no matter which chord has been selected, we always want to send the message 0. Let's see, S reset counter. And I will create an R reset counter here to the third inlet. Okay, and this will reset the counter. So if it has not reached the max value, it will go back to 0, meaning it will not trigger the end of the melody as long as I'm playing chords, which can be useful. So if I, stop playing, then the melody ends, or I can have continuous melodies. And lastly, I want to make it so I start playing the melody if I'm not playing the melody right now. Meaning, if there is already a melody playing, if this toggle is on, do not do anything. But if this is off, turn it on. And this is very easily achieved by sending the message 1 to this toggle. The message 1 will always turn it on. So if it's on, nothing will change. If it's off, it will turn on. And again, I want to do this regardless of which chord has been detected. In any case, if any chord is detected, just turn this on, or if it's on, keep it on. So let's see, S toggle melody. And I'm going to send this message to my main toggle. Okay, and wait, there's one more thing. Oh my god, things keep popping up. I also want to reset this, my starting points, if I am starting from scratch. What does this mean? If the toggle melody is off, if this toggle is off and I'm turning it on, if I'm starting a new melody from scratch, I always want to start from the same position, this int 30. I want to trigger this 30 message so that it goes into the second inlet. So I have to detect transitions from 0 and 1. And I believe tog edge is going to do that. Tog edge is going to receive the output of a toggle, and it's going to, let's see, let's experiment with this a little bit before I start talking like I know what I'm talking about. So if I remember this right, if I turn it on, it's going to send a bang out from its first outlet. If I turn it off, a bang out from its second outlet. Okay, perfect. So if I'm turning this on, I can simply send that bang to this 30 message sent to my int 30 object, meaning that I load the value 30 as my starting note. Okay, now here comes the moment of fate. Let's see if this works. It works. Great. And now if I start again, it should start from somewhere in the middle. This chord is not detected. Perfect. Okay, I honestly think this is it, but one more thing I want to do is to have an elongated note at the end, meaning if it's the end of the melody, or if there is nothing being played, I want the current note to extend. And to do this, I can use a neat trick. I can use the stop message, which is going to stop the currently playing notes that is sent out by make note. And I can then change the second argument of make note, which is the length of the note in milliseconds. Let's make it 2000. So 2000 milliseconds, 2 seconds. And now if I trigger a note, it is going to go on for 2 seconds. But if I trigger another note, it's always going to first send the stop message, which stops the currently playing note, and then play the next note, which will essentially make it so that the final note in our melodic sequence will be 2 seconds long. There we go, a fairly complicated algorithm, but I hope this explanation, this recreation made it a bit easier for you to understand how to work with slightly more complex algorithms, and you can definitely improve this algorithm, right? For example, I can immediately think of this random selection process. Would it be possible to add other possibilities, maybe larger interval jumps, and more importantly, would it be possible to change the random chance here? Would it be possible to give a different percentage to the chance of each of these steps, each of these possibilities happening? So maybe it's more likely that the melody is going to go up instead of down, or maybe it would be possible to mess with this tempo object, the rhythm of the bangs here, so there are different rhythmical possibilities. I think it's definitely worth playing around with this algorithm, create your own variations, improve upon it, and create really cool music. Thank you for watching.